Hello friends, this video on chemical reactions and equations part 12 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 11. Now we'll discuss the acid-base reactions, another type of reactions, acid-base reactions. And please note this also will come in one of the five, the basic properties, the basic classification of the chemical reaction. It will come in one of those five depending on the reaction I'm talking about. So general form is acid plus base is equal to salt plus water. So since it is acid plus base equal to salt plus water, so it is like reactants of a base and the acids, they react and the product is salt and water. Right? So the positive ion of hydrogen of the acid and the negative of this hydroxyl ions, they lose electrical charge and becomes covalent molecular with the water. So you don't understand this line, you can forget this line now. You'll understand this more when you learn the covalent bond thing. Just understand in acid base what happened is you have this reactants of the acids and base and the product is salt and water. And generally it is a double displacement reaction. Generally in case it's a double displacement reaction. And so acid-base reaction actually is nothing but a neutralization reaction, because what you're doing is you have a acid, you have a base, and finally you're getting the solid, it's neutral, right? So it's also called a neutralization reaction. Both are same. You tell acid-base reaction, your neutralization reaction, both are same actually. For example, I'll take one example. You have hydrochloric acid as the acid, plus you take a base and AOH. You know that base has OH. And if you don't know, next chapter we are going to, next chapter will go for as acid and base. So you have acid and base, you react, you get NaCl, there's a salt plus water. This is a typical acid-base reaction. And if you see here, the chlorine is pairing up with Na to get NaCl, and H is pairing with OH to get water, right? H2O. Water is H2O. This is a typical double displacement reaction where you have acid and base, they combine to form a salt, and also called a neutralization reaction. Now we'll talk about exothermic and endothermic reaction. So it all depends on the heat. So if it gives out heat, it's exothermic. If it takes hits, it's a endothermic reaction, right? So if heat is given out, it is exothermic, and if the heat is absorbed, right, and it is absorbed, it is an endothermic. So for example, so we have this magnesium and we have oxygen. You heat it, right? You heat it, you get magnesium oxide. So in this case, the heat was required, right? So it is a endothermic reaction. But if you see a reaction, combustion reaction, for example, you have any substance, or you have this lime water, you have COO, you add with water or carbon dioxide, I think, right? So you get CaCO3 plus heat, right? So in this case, if you see, this guy is giving out heat, so it's an exothermic reaction. So you can see that this is a different classification altogether. So these also fall in one of these five. So it may happen that you get a combustion reaction as exothermic. You also may get a synthesis reaction as exothermic. You may get a this kind of decomposition reaction as exothermic. You may also get a replacement or double displacement reaction also as a exothermic reaction. Similarly, the case with endothermic. So this classification is not based on the product numbers and the replacement it makes. This is solely based on the heat. If it emits heat, it is exothermic. If it requires heat, it is endothermic, right? But end of the day, typically it will be part of one of these reactions, and it depends on the equation I'm talking about, right? You can't say that all the exothermic reactions are decomposition reactions or synthesis reaction or double displacement reaction. It can be any of these depending on the equation I'm looking for. But this is a different classification. If it takes heat, exothermic. Sorry, if it takes heat, it's an endothermic. If it emits heat, it's a exothermic reaction. Now the question is, why is respiration considered as exothermic reaction? So in the exothermic reaction, if you see, we have the heat is given out, and we see that in respiration what happened is we have this food oxygen is taken. With this we get energy and we get heat. Right? This is the typical example of the or typical equation for this respiration. In this case, if you see the heat is coming out. Since the heat is coming out, this guy is an exothermic reaction. Hope you understand this. In case of respirations, you have this food in presence of oxygen, the body using some catalyst and enzymes, right? So this guy produces energy and heat. It comes out of this reaction. So it's a exothermic reaction. Now we'll understand redox reaction, nothing but oxidation and reduction reaction. It's a very critical reaction. So reaction that involves loss or gain of hydrogen is called redox reaction. So if you are gaining oxygen, gain of oxygen or loss of hydrogen, that is oxidation. You are losing oxygen or gaining hydrogen, that is reduction, right? So you gain oxygen. So if you're gaining oxygen or losing hydrogen, it's oxidation. So oxidation means gain oxygen. Reduction means lose oxygen. Correct? So for example, if you have this copper, you have oxygen, you heat this copper, right? In terms of oxygen, it becomes COO. So in this case, if you see, the copper is gaining oxidation, oxygen. So you can say that copper is oxidized. Again, this copper you again heat in the presence of hydrogen now. So if now again see, the copper is losing electron, losing oxygen. So in this case, you see the copper is reduced and hydrogen is gaining oxygen now, right? Hydrogen was H2, it becomes H2O. We can say that hydrogen is oxidized. Correct? So anything that gains electron, gains oxygen is oxidized. In this case, copper is oxidized. Here hydrogen was gaining oxygen, hydrogen oxidized. Anything that loses oxygen is called the reduction force. In this case, the copper lost oxygen. Same thing for hydrogen. If something loses hydrogen, that is oxidized. Something gains hydrogen, that is reduced. We'll study all this reaction in the later chapter more in deep. Corrosion is an example of a redox reaction in daily life where this things you see is it gets corroded, right? So it was a good looking object and this thing became rusted. So what happens in corrosion is and the question is, why do you apply paints in an article? Because we don't want this iron to come in touch with oxygen. So what happens is you have this iron, it comes in oxygen, this gives a reaction, it's called Fe2O3 and that is nothing but rust, which you see here. To avoid this oxygen, we paint this. So if you avoid this oxygen, if you paint this, the iron won't come into contact with oxygen and this Fe2O3 won't be created and then the resting will be provided. And why this is happening? This is the redox reaction. Why? Because the iron is gaining oxygen. So iron is oxidized here. Correct? So we'll study more in deep about oxidation and reduction in class 11. Just in this chapter, the concept was to make you understand the 5 basic type of reactions we have, right? And other reactions we should generally use, for example, redox reaction, acid-base reactions. One ratification reaction is also one example of redox reaction in real life. So if you see the food which you have, which you keep in some time in dry place, it gets a bad smell. Why a bad smell? Because this guy has fat and oil, right? This thing get oxidized and they become rancid and their taste is very bad. This is one example of redox reaction in daily life, right? And that's why what we do is we keep this food in an airtight container, right? And also if you see the chips which you get, the chips, Uncle Chips and Lay's and all the chips you get, they are packed in this wrapper and they are all airtight. And this inside that they put some nitrogen so that they don't come in contact with oxygen, and these prevent these things to get oxidized. Because if it's oxidized, it gets spoiled first. If you see the pickle also we have in homes, right? That is dipped in oil. So this pickles which we have is really dipped in oil. Why? Because in oil, if it is an oil, it won't get contact with oxygen. If you don't get contact with oxygen, it won't get rancified and it won't get spoiled, right? So that's one way to prevent these things from getting rancified. So what we have learned the chemical equation definition, that it represents reactant, product and the physical state symbolically, and the chemical equation has to be balanced always, right? The law of conservation of mass. So in combination reaction, we have two or more substances to form a single composition. In decomposition reaction, we have one compound bringing two or more substance. So in displacement reaction, we have one element displace another one. In double displacement, we have both the elements swap, right? And the reaction where heat is given out is called exothermic. The reaction where requires heat is called endothermic, right? This we have learned. We have learned the oxidation is nothing but the process of gaining of oxygen or losing hydrogen, and reduction is the reverse process of losing oxygen or gaining of hydrogen. That's what we have learned. Thank you. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.